Hello everyone, welcome to the study guide videos. So let's get started on page 1 here. It says use the graph of the rational function f to answer the following. Find the domain. Well, the domain is all real value or all real numbers except the excluded values. So I need to figure out what my excluded values are. And looking over here, we can see I have a hole at x equals 5, so x can't equal 5. That's one of my excluded values. And I have what appears to be a vertical asymptote on this little dotted line right here. So that is at 4. So x can't equal 4. So there are my excluded values, which means I should have 2 breaks in my number line where those real values or those values are excluded. So the domain is going to start at negative infinity all the way to the excluded value number 1, which is 4, union 4 all the way to excluded value number 2, which is 5, union, and then excluded value 2 to positive infinity. And there is my domain for the function. All real numbers except excluded values. The zeros, find the zeros. Those are x-intercepts, and it looks like there is an x-intercept here, right there at 3. So it looks like x equals 3 is an x-intercept. It might come in later, but see how it bounces off the graph. This is going to have a multiplicity of 2. Not sure if it'll come in later, but we'll make a note of it just in case. Find the in behavior of f. So in behavior is what happens as x goes to infinity, and we're going to write that in limit notation. So over here, as x goes to negative infinity, that is my in behavior. So the limit of our function, which is f, the limit of f as x approaches negative infinity. So as x gets smaller, the y value seems to be approaching what this looks like, a horizontal asymptote here at 1. So it should be 1. There is a horizontal asymptote there at 1. And then the other side, the limit of our function as x approaches positive infinity, that is also going to 1. It is the horizontal asymptote. So if there is a horizontal asymptote, that will always be your in behavior. Find the limit notation of the vertical asymptote. So the vertical asymptote happens at x equals 5 is our vertical asymptote. So we need to know what is happening to the function as x approaches this excluded value, which is 5. And it matters, since this is middle behavior, we can approach it from either direction, either left or right. So let's check the left side first. So right here is that value, and as I approach this, 5, sorry, I read that wrong. This should be 4. My x asymptote is at 4, or my vertical asymptote's at 4. So let's fix that real quick. There we go. As I approach 4 from the left side, the y value is rocketing upwards towards infinity. So that should be positive infinity. And then I need to check it from the right side. So the limit of my function as x approaches positive 4 from the right side. And so I start over here to just to the right of 4, and I see what happens as I get closer. Well, the graph is still going up. So this would also be positive infinity. And then finally it says find the limit notation of the hole. Well, the hole is right here. It looks like this hole is at 5, 4. So it looks like the xy coordinates are 5 and 4. Now we could look at the left and right for our removal discontinuity here. And so as I approach from the left side, it is approaching 4. So as I get closer to 5 from the left, I'm getting closer to 4. As I'm getting closer to 5 from the right side, it is also going towards this y value of 4. So instead of having to write both left and right, since they're both going to one single finite value, we can combine it into one expression. The limit of f of x as x approaches 5 is equal to 4. There we go. Okay, let's move on to question 2. So here we're given another rational function. Let's see if I can zoom in a little bit here. Nope, camera's not that fancy. So we're given another rational function. Rational functions, these are both polynomials. They're both in standard form, and I don't like polynomials in standard form in dealing with rational functions. It's just easier to work in factored form. So let's quickly factor these. On top, all of these have a common factor of x, so I can change this to be x times, and then we'll reduce all of these by an x. So that's x squared minus 2x minus 15 all over. Down here, let's see if I can factor it. I need a number that multiplies to be negative 6 and adds up to be two numbers that multiply to be negative 6 and add up to be positive 1. So we can factor this real quick to x plus 3 and x minus 2. We can still factor one more over here. So I want to factor this quadratic. I need two numbers that multiply to be negative 15, add up to be negative 2. So this will be negative 5 and positive 3. So there is my factored rational function. Okay, step 1. Find the domain. Well, the domain is all real numbers except the excluded values. My excluded values over here are going to be, so x can't equal a negative 3, and x can't equal a positive 2. So those are my two excluded values. So I'm going to, negative 3 is the smaller one, so that is my excluded value 1. So my domain should be negative infinity all the way to the first excluded value, which is negative 3, union negative 3 all the way to my next excluded value, which is 2, union that excluded value all the way up, all of excluded values, so we can go all the way to infinity and finish it off. So two excluded values, two union symbols. The zeros, so the zeros occur when the numerator is equal to 0. So excluded values occur where the denominator is 0, but when the numerator is 0, that's just a 0 of the function. So I have 3 factors, so I should have 3 zeros. This first one's going to be x equals 0. This one is x equals a positive 5, and then we'll have x equals 3. So you can write that like that, or you can write it as a list. So this one is the 0. This one is the x equals 5. And this one's the x equals negative 3. So there are my zeros. Find the y-intercept. So the y-intercepts occur. So when g of 0, so we plug in 0 for everything. This is the one time when I actually prefer to use the standard version. The standard version works out much better because a lot of things just start canceling out. So this will be 0 to the third power minus 2 times 0 squared minus 15 times 0 all over 0 squared plus 0 minus 6. So 0 cubed is 0. 2 times 0 squared is 0. 15 times 0 is 0. So on top, I'm just left with 0. On bottom, I'm left with, well, that cancels out, a negative 6. So that g of 0 is equal to 0. So my y-intercept should be 0, 0. The origin. The origin. Find any holes if there are holes. So a hole will occur if there is a common factor on top and bottom. And over here, I see that I have x plus 3 on bottom and an x plus 3 on top. X minus 2 does not have a partner, so that's going to be an asymptote. So then I know that I should have a hole. So the hole should occur at, there should be a hole at x equals negative 3. But we need to find out what the y value of that hole is. So after I simplify it, I need to do f of negative 3, but the simplified version of this. So we're going to ignore these factors. So that is going to be a negative 3 times negative 3 minus 5. Make those parentheses a little bit bigger. So that's my top, negative 3 times negative 3 minus 5 over, this is going to be a negative 3 minus 2. And then we just got to simplify this. So negative 3 stays there. Negative 3 minus 5 is a negative 8. All over negative 3 minus 2 is a negative 5. So we should get the number, that's negative 3 times negative 8 is a positive 24. And then negative 5 is just negative 5. So that's going to be a negative 24 over 5. So the whole is negative 3, negative 24 over 5. Because we need the y value of that whole. Next up, find a vertical asymptote if there is any. So the vertical asymptote is any excluded value that's not a whole. This right here should be at x equals 2. So x equals 2 is a vertical asymptote. Let's put boxes around my answers here. Okay. Find the horizontal asymptote if there is one. So a horizontal asymptote. So we got to compare the degree on top with the degree on bottom. It doesn't matter if we use this version or this version, but the degree on top is, as we can see, is 3. So I have a degree 3 on top, a degree 2 on bottom. Since the degree on top is bigger, that means that there is no horizontal asymptote. There is none. And then slant asymptotes, we are not working on those right now, so we can ignore that one. Okay, so that completes page number 1. I will see you in video 2.